Let's look at a few more things about colors. These are called disruptive coloration. So very large, bold patterns and contrasting colors. So they are either for blending into the background, like typically they occur in corals. Tropical fish tend to have lots of colors. People with aquaria love to have colorful tropical fish. It could be also for attracting mates. If you look on land, for example, birds of passion and many other birds and insects, butterflies, and so on also tend to have lots of coloration. Sometimes it scares away the predators because they look toxic. On land, at least, there are also insects that imitate others. They clone others, so they don't produce a toxin, but they make themselves look like another insect that actually produces a toxin, and so on and so forth. So the fascinating thing about biology continues even in the ocean. In other words, we don't know exactly why these bold, bright colors exist. We don't always know that. Okay? Water pressure. We already talked a little bit about diving, but just to repeat it, you have so you start at the sea level, which is the 1 atmosphere pressure. With each 10 meters, it increases by 1 atmosphere. You can imagine if you go down a few kilometers, how much pressure there is going to be. Just like we walk around in the atmosphere without feeling the atmospheric pressure on our lungs and so on, the fish that have evolved at different depths have also evolved to balance the pressure in their body fluids and the outside pressure, right? But if there is a fish that actually takes a dive for whatever reason, let's say to find food or to avoid predation or just for fun and so on, they have to have a way of tolerating the rapid pressure change. Unlike in the atmosphere, you have much faster pressure change in the ocean, 1 atmosphere per 10 meters. So things like sperm whales, which breathe the air, not through the gills, so they actually have collapsible rib cages. So they want to dive for hours to very deep depths where the pressure increases. They have to get rid of all the air bubbles inside, otherwise the pressure is going to create huge problems, right? Lungs can explode and so on. So they have collapsible rib cages which squeeze out all the water and leave no inner air pockets, which is very common for marine organisms in general. So they breathe the water, take the dissolved oxygen, get rid of the CO2 and so on, without keeping any air pockets inside to avoid these pressure issues. So many fish also have swim bladders. So you can see here an example. This adjusts buoyancy, so it can regulate its depth. Okay, just because it regulates its depth doesn't mean that's also allowing it to manage pressure differences. It has to have other evolutionary features that allows it to manage the pressure changes. Humans also have a long history of diving into the ocean around corals to find shells and other things. History of human diving goes back almost 4,500 years. Simple things like a wok or a kadai with air is used to go down a few meters, and then in the before the 1940s, a kettle had evolved with pipes that you can attach, kettle filled with oxygenated air that you could take for a dive. In the 1940s, Jacques-Yves Cousteau, the famous ocean explorer who made some fantastic discoveries, and his son also continues to do that, along with another inventor, invented something called scuba, self-contained underwater breathing apparatus, scuba, which made diving much more easy, much more fun, and now lots of tourism is focused around diving. You can go take diving lessons, get permitted to take a dive to certain depth. Typically, nobody goes beyond about 30 to 100 meters. That's kind of the maximum. There have been some crazy experiments where people use compression suits and so on, went down to 500 meters. There have also been deaths with such experiments and so on. So ocean holds great fascination for humans. Diving is a big part of this fascination, obviously. But this pressure difference has to be kept in mind. Also, when the pressure increases, more nitrogen dissolves into human blood through the skin, and that can create some temporary neurological disorders. So if you come back up very quickly, nitrogen bubbles can form, and you can have what are called nitrogen bends. Apparently the joints begin to ache and the divers bend over, so it's called nitrogen bend. It can cause hallucinations and also serious problems. You can die if you're not careful. So you cannot move up very quickly. And even when you catch a fish that's pretty far deep, there are examples where you pull it up too quickly to the surface, and the pressure change makes the fish explode because the body fluids are coming from under a very high pressure to the atmospheric pressure. So be careful when you fish a deep water fish, right? Okay. Pressure, another adaptation feature needed for living in the ocean.